Here is the summary of this video. What is the issue? Lorentz transformations are the foundation for relativity theory calculations, such as the gamma factor, kinetic energy, and the addition of relativistic velocities. If the derivation of the Lorentz transformation was false, the theory of relativity would collapse. In this fourth video, we will critically examine the derivations which postulate that these equations must be linear. Previously, in the previous videos, we saw that these were specific reference frame S and S', where the origins of place and time coincide. In addition, the demonstration only concerns a light wave emitted at O and O' at the instant t equals t' equals 0. In the usual demonstrations, y' is equal to y, there is a link between x' and x, and v' equals minus v. During our analyses, we were unable to establish these links. Derivations.
There is a simple requirement that has to be satisfied by these kind of transformation equations, and the requirement is that these transformation equations, which relates x, y, z, t and x dash, y dash, z dash, t dash, must be linear in nature. Now, why do they have to be linear? They have to be linear because we want, first of all, a one-to-one relationships, and second of all, we do not want accelerations creeping out due to the transformation equations themselves. So for
t prime transformations, we take an arbitrary set of constants as coefficients for our x and t, and through four scenarios we derive what these coefficients have to be.
These transformation equations must be linear in nature. We take an arbitrary set of constants as coefficients for our x and t. These are not arguments. Why linear equations? Are they the single solution? Why not nonlinear equations, as for example an hyperbolic tangent, or any other form? Criticism. Let us have 4 points, A, B, D and E. We decide that if there is a circle that goes through these 4 points, it is the only solution. Okay, and it is especially the only solution to my problem. But the solution to my problem can also be, in fact, an ellipse. Or another ellipse. Galileo Galilei had the same problem. He wanted to demonstrate that the planets revolved around the Sun, okay, but with a circular orbit. As this worked more or less well, it was necessary to add epicycles. And Kepler found another solution, ellipses. Linear is one solution, but other nonlinear equations could be solution too. And the trouble with the linear solution, it is based on v' equals minus v. About velocities, please check again previous video, part 3. Results. We failed to establish that these equations should be linear. Because linear equations are a possible solution, but not necessarily the set of possible solutions. And what do you think?